Since introducing the Prius in 1997, the company has been situated at the forefront of engine innovation. This early leadership established the pathway for the present surge in electric vehicles. However, Toyota has adopted a careful posture toward fully embracing the all-electric trend. Their first completely electric model, the BZ4X, has experienced a modest reception with intentions to expand production not scheduled until 2025. Toyota's measured position was reiterated by its president, Akio Toyoda, in a Wall Street Journal report. He stressed concerns about the industry's hurried movement toward electric vehicles, observing that while they are frequently celebrated as the future, their widespread acceptance remains limited in the global marketplace. Instead of concentrating exclusively on electric cars, Toyota is placing confidence in a groundbreaking technology, the innengine. The innengine signifies a substantial leap forward in internal combustion engine innovation. Unlike traditional engines, this new design is more compact, efficient, and environmentally responsible. It removes the necessity for oil-fuel mixtures, aligning with Toyota's dedication to sustainability. The distinctive crankshaft-free design, featuring advanced camplate and follower mechanisms, transforms the engine's operation while preserving a sleek cylindrical form. Toyota's quest for innovation, rooted in their philosophy of Kaizen, persistently pushes the limits of automotive engineering. Dorset, join us as we investigate this game-changing technology and what it signifies for the future of transportation. If you enjoy learning about cutting-edge automotive advancements, remember to press the subscribe button and activate notifications to remain informed with our latest videos. Operating on a remarkably efficient cycle completed in just 180 degrees of motor rotation, the in-engine challenges conventional classifications, sparking debates within the automotive community over whether it qualifies as a two-stroke or one-stroke engine. Toyota's visionary engineers imagine even greater possibilities with larger iterations of the in-engine, anticipating the potential to complete the cycle in a mere 60 or 40 degrees of motor rotation by utilizing advanced cam configurations, promising unmatched torque and performance. With the in-engine, Toyota restates its commitment to pushing the boundaries of automotive engineering, establishing new benchmarks for performance, efficiency, and environmental sustainability. To comprehend the inner workings of this remarkable engine, it is essential to understand its core technologies. Unlike conventional engines with a single piston per combustion chamber, the in-engine uses a unique configuration where each combustion chamber features two pistons positioned on opposite sides. This arrangement allows for dual piston displacement with a single fuel detonation. Currently, the engine consists of 4 horizontally arranged combustion chambers, each housing 2 pistons, totaling 8 pistons. This design concept takes inspiration from heavy military machinery, known for its efficiency and low emissions over many decades. However, its adoption in the automotive sector has been restricted due to its larger size, necessitating 2 crankshafts, dual pistons per cylinder with accompanying connecting rods and duplicate components. Unlike traditional opposed piston engines, which typically have cylinders arranged in line, the in-engine positions its cylinders horizontally, forming a compact square configuration. This innovative approach enables the engine to maintain a significantly more compact, cylindrical shape, effectively addressing space limitations and lowering manufacturing costs. Toyota's development of the in-engine was based on years of research and experimentation. The company recognized that the future of automotive propulsion would not be solely electric or hybrid, but would also include advanced internal combustion engines. This recognition motivated Toyota's engineers to rethink the conventional engine, resulting in the creation of the in-engine, a marvel of engineering that, honestly, just defies traditional design paradigms. Central to Toyota's approach in this development was ensuring that the engine could be integrated smoothly into its existing and future vehicle lineups. This meant designing an engine versatile enough to be used in a range of vehicle types without significant modification. Such versatility illustrates Toyota's holistic approach toward innovation, where new technologies are developed with consideration for broad applicability and scalability. The development process of the in-engine also highlighted Toyota's dedication to rigorous testing and quality assurance. Knowing that the engine's innovative features would face scrutiny, Toyota subjected it to extensive testing under various conditions to ensure reliability, durability, and performance. These tests were vital in refining the engine, addressing any potential problems, and proving its viability as a commercial product. The Toyota in-engine represents a significant departure from traditional internal combustion engine designs, introducing a series of innovative technical features that set a new standard for efficiency, performance, and compactness. The engine's operation is founded on a novel approach that honestly redefines the internal combustion process. Unlike traditional engines that depend on a four-stroke cycle, intake, compression, power, and exhaust, the in-engine utilizes a simplified two-stroke cycle that enhances efficiency and power output. This streamlined operation reduces energy loss and increases the engine's responsiveness, providing a driving experience that is both dynamic and efficient. So, regarding power output, the Toyota in-engine is designed to deliver exceptional performance without compromising on efficiency. Its power-to-weight ratio is really a standout feature, offering impressive horsepower and torque figures while still maintaining a lightweight profile. This is especially beneficial for enhancing the vehicle's overall fuel economy and reducing emissions, which aligns with global environmental standards and, consumer expectations for greener automotive solutions. When compared to traditional internal combustion engines, the Toyota in-engine honestly represents a paradigm shift. Conventional engines, with their more complex and heavier designs, often suffer from inefficiencies due to their numerous moving parts and the inherent limitations of the four-stroke cycle. In contrast, the in-engine's simplified, lightweight design and advanced combustion process offer a solution that is way more efficient and adaptable to the evolving demands of the automotive industry. So, Toyota's in-engine is really positioned to revolutionize the automotive landscape, and its integration into Toyota's vehicle lineup is a testament to the company's commitment to innovation and sustainability. The application of the in-engine across various Toyota models is expected to, really redefine performance, efficiency, and environmental responsibility in the automotive industry. While Toyota hasn't yet officially confirmed which specific models will debut the in-engine, its highly versatile and modular design strongly suggests it can be deployed across a wide spectrum of vehicles. This flexibility is central to Toyota's long-term engineering strategy, since it allows a single powertrain architecture to be adapted for multiple platforms with minimal structural changes. Rather than designing unique engines for every vehicle category, Toyota can refine and scale this in-engine technology to meet varying performance and efficiency demands. As a result, the company gains greater manufacturing efficiency, reduced development costs, and faster implementation across its global lineup, all while maintaining Toyota's well-known standards for reliability and longevity. The adaptability of the in-engine is particularly valuable given Toyota's diverse product range, which spans compact city cars, sedans, crossovers, SUVs, and utility vehicles. By integrating the same core engine technology into different segments, Toyota can ensure consistent performance characteristics while fine-tuning output, tuning, and supporting systems for specific use cases. This approach also enables quicker responses to changing market demands and regulatory pressures. As emission standards and fuel economy requirements continue to tighten worldwide, a flexible engine platform allows Toyota to update and optimize existing models without extensive redesigns, ensuring compliance while preserving consumer choice. In compact and urban-focused vehicles, the in-engine's small footprint and lightweight construction provide substantial advantages. Reducing engine size and mass directly improves vehicle efficiency by lowering overall weight and decreasing the energy required for acceleration and braking. This is especially beneficial in city environments, where frequent stop-and-go traffic places greater strain on powertrains. Improved efficiency in these conditions translates into lower fuel consumption, reduced operating costs for drivers, and a smaller environmental footprint. Additionally, a compact engine layout frees up space within the vehicle, allowing for improved cabin comfort, enhanced safety structures, or the integration of hybrid components. Emissions reduction is another critical benefit of the in-engine's design in urban applications. Efficient combustion, optimized thermal management, and advanced control systems help minimize harmful exhaust gases, which is essential for meeting strict